Article 110.33 of the National Electrical Code states that service equipment, switchboards, panel boards, and distribution boards shall be located in an accessible location where they will not be subject to physical damage, excessive temperature, or environmental deterioration. Pull-down stairs are not considered permanent ladders under the NEC because they are not fixed in place and can be easily moved or removed. Since pull-down stairs are not considered permanent ladders, they do not meet the requirements of 110.33 for accessing a panelboard location. Therefore, one cannot install a panelboard in the attic using pull-down stairs for access. Other code requirements exist. Firstly, accessibility. The panelboard must be easily accessible and within 6 feet of a floor according to 110.26 CE. Secondly, headroom. There must be at least 6.5 feet of headroom above the panelboard as outlined in 110.26 D. Thirdly, illumination. The panelboard must be located in a well-lit area as specified in 110.26. Fourthly, damp or wet locations. The attic must be dry and not subject to excessive moisture or condensation, adhering to 110.11. Based on these considerations, it's important to ensure any electrical installation complies with all relevant NEC guidelines. Considering accessibility, 110.26 covers working space. Working space requirements are intended to provide sufficient room for personnel to safely operate and maintain electrical equipment. This includes minimum distances, heights, and widths. For instance, 110.26 AON dictates the depth of the working space in front of electrical equipment. The depth depends on the voltage to ground and the condition of the installation. Condition 1 involves exposed live parts on one side and no live or grounded parts on the other side of the working space, or exposed live parts on both sides effectively protected by insulation or other means. Condition 2 involves exposed live parts on one side and grounded parts on the other side. Condition 3 involves exposed live parts on both sides of the working space that are not guarded or insulated. The minimum clear distance is for 150 volts to ground, 151 volts to ground to 600 volts to ground, and 601 volts to ground to 2500 volts to ground vary depending on the condition. For example, for 150 volts to ground under condition 1, the minimum clear distance is 3 feet, while for 601 volts to ground to 2500 volts to ground under condition 3, it increases to 4 feet. The width of the working space, as per 110.26 ATWO, should be at least 30 inches wide or the width of the equipment, whichever is greater. This ensures adequate lateral movement for personnel working on the equipment. The height of the working space, according to 110.26 AFRI, should be at least 6.5 feet or the height of the equipment, whichever is greater. This provides enough vertical clearance for safe operation and maintenance. Access to the working space is also critical. 110.26C requires that the working space be readily accessible. Obstructions that could impede access are not permitted. Clear and unobstructed access ensures that personnel can reach the equipment quickly and safely in case of an emergency or for routine maintenance. Illumination, as covered in 110.26D, mandates adequate lighting for the working space around electrical equipment. Proper illumination enhances safety by allowing personnel to see clearly and avoid potential hazards. The lighting should be arranged to minimize glare and shadows, providing a well-lit environment for performing tasks safely. Finally, 110.26E addresses the presence of foreign equipment. The working space should not be used for storage or other purposes that could obstruct access or create hazards. Maintaining a clean and uncluttered working space is essential for safety and efficiency. Considering panelboard installations in damp or wet locations, 110.11 emphasizes that electrical equipment must be suitable for the environment in which it is installed. This means that in damp or wet locations, equipment must be designed and constructed to prevent moisture from entering and causing damage or creating a safety hazard. Enclosures for panelboards in such locations should be weatherproof or waterproof, depending on the severity of the moisture exposure. Additionally, proper drainage and ventilation should be provided to minimize condensation and prevent the accumulation of moisture inside the enclosure. Grounding is another critical aspect of electrical safety. A properly grounded electrical system provides a low impedance path for fault current to flow back to the source, allowing overcurrent protection devices to trip and clear the fault quickly. Grounding helps to minimize the risk of electric shock and equipment damage. The NEC provides detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the methods for connecting grounding electrodes, and the bonding of metal enclosures and equipment. Overcurrent protection is essential for protecting electrical circuits and equipment from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The NEC specifies the types and sizes of overcurrent protection devices required for different types of circuits and equipment. Proper overcurrent protection helps to prevent fires, equipment damage, and electrical hazards. Wiring methods play a significant role in the safety and reliability of electrical installations. The NEC specifies the types of wiring methods that are permitted for different applications, taking into account factors such as the environment, the voltage level, and the type of occupancy. Common wiring methods include rigid metal conduit, electrical metallic tubing, non-metallic conduit, and cable assemblies. Each wiring method has its own advantages and limitations, and the selection of the appropriate wiring method is crucial for ensuring a safe and compliant installation. Conductor ampacity is the maximum amount of current that a conductor can carry continuously without exceeding its temperature rating. The NEC provides tables that specify the ampacity of different types and sizes of conductors, based on factors such as the insulation type, the ambient temperature, and the number of conductors in a raceway or cable. It is essential to select conductors with adequate ampacity to ensure that they can safely carry the intended load current without overheating or causing a fire hazard. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to operate inefficiently or malfunction, and it can also lead to overheating of conductors and insulation. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To minimize voltage drop, it is important to select conductors with adequate size and to keep circuit lengths as short as possible. Arc fault circuit interrupters, or arc fault circuit interrupter breakers, are designed to protect against electrical fires caused by arc faults. An arc fault is an unintentional electrical discharge that can occur when damaged or deteriorated wiring creates a high resistance connection. Arc fault circuit interrupter breakers are required in many areas of the home, particularly in bedrooms, living rooms, and other areas where occupants are likely to be present. Ground fault circuit interrupters are designed to protect against electric shock caused by ground faults. A ground fault occurs when current leaks from an electrical circuit to ground. Ground fault circuit interrupter receptacles are required in bathrooms, kitchens, and other areas where water is likely to be present. They quickly interrupt the flow of current when a ground fault is detected, minimizing the risk of electric shock. Electrical inspections are an essential part of ensuring the safety and compliance of electrical installations. Electrical inspectors review plans and inspect installations to verify that they meet the requirements of the NEC and other applicable codes and standards. Electrical inspections help to identify potential hazards and ensure that electrical systems are installed and maintained safely. Permits are typically required for electrical work to ensure that it is performed in accordance with applicable codes and standards. Obtaining a permit involves submitting plans and specifications to the local building department for review and approval. Permits help to ensure that electrical work is performed by qualified individuals and that it meets the required safety standards. Safety training is essential for all individuals who work on or around electrical equipment. Safety training should cover topics such as electrical hazards, safe work practices, the use of personal protective equipment, and emergency procedures. Proper safety training helps to minimize the risk of electrical accidents and injuries. Personal protective equipment includes items such as rubber gloves, safety glasses, and insulated tools. Personal protective equipment is designed to protect workers from electrical hazards such as electric shock, arc flash, and burns. It is essential to use the appropriate personal protective equipment for the task at hand and to inspect it regularly for damage or defects. Lockout-tagout procedures are used to ensure that electrical equipment is de-energized and locked out before work is performed on it. Lockout-tagout procedures involve disconnecting the power source, locking the disconnect switch in the off position, and tagging it with a warning label. Lockout-tagout procedures help to prevent accidental energization of equipment and protect workers from electrical hazards. First aid and emergency procedures should be in place to respond to electrical accidents and injuries. First aid procedures should include steps for treating electric shock, burns, and other electrical injuries. Emergency procedures should include steps for calling for help, evacuating the area, and shutting off the power. Regular maintenance is essential for ensuring the continued safety and reliability of electrical systems. Regular maintenance should include inspecting equipment for damage or wear, testing overcurrent protection devices, and tightening connections. Proper maintenance helps to prevent electrical failures and extend the life of electrical equipment. Documentation is important for tracking electrical work and ensuring that it is performed in accordance with applicable codes and standards. Documentation should include plans, specifications, permits, inspection reports, and maintenance records. Proper documentation helps to provide a record of the work that has been performed and ensures that it meets the required safety standards. The NEC is updated every 3 years to reflect changes in technology and best practices. Staying up to date on the latest edition of the NEC is essential for ensuring that electrical installations are safe and compliant. The NEC is available for purchase from the National Fire Protection Association and other sources. Continuing education is important for electrical professionals to stay up to date on the latest codes, standards, and technologies. Continuing education courses are available from a variety of sources, including trade associations, educational institutions, and manufacturers. Participating in continuing education helps to ensure that electrical professionals have the knowledge and skills necessary to perform their work safely and effectively. Professional licensing is required for electrical contractors and electricians in many jurisdictions. Licensing ensures that individuals who perform electrical work have the necessary qualifications and experience. Licensing requirements typically include passing an examination and completing a certain amount of apprenticeship or on-the-job training. Adhering to manufacturers' instructions is crucial when installing and maintaining electrical equipment. Manufacturers provide detailed instructions on the proper installation, operation, and maintenance of their equipment. Following these instructions helps to ensure that the equipment is installed and operated safely and effectively. Using the right tools for the job is essential for safety and efficiency. Electrical work requires specialized tools that are designed to be safe and effective for working on electrical equipment. Using the wrong tools can lead to accidents and injuries. Proper planning is essential for any electrical project. Planning should include assessing the scope of the work, identifying potential hazards, and developing a plan to mitigate those hazards. Proper planning helps to ensure that the project is completed safely and efficiently. Good communication is essential for any electrical project, especially when working with others. Communication should include discussing the scope of the work, identifying potential hazards, and coordinating tasks. Effective communication helps to prevent misunderstandings and ensure that the project is completed safely and efficiently. When working with electricity, it is important to be aware of the potential hazards and to take steps to mitigate those hazards. Electrical hazards include electric shock, arc flash, and burns. By following safe work practices and using the appropriate personal protective equipment, it is possible to minimize the risk of electrical accidents and injuries. Always double-check your work to ensure that it is correct and safe. Before energizing any electrical circuit or equipment, it is important to double-check your work to ensure that all connections are tight, all wires are properly insulated, and all safety devices are in place. Double-checking your work helps to prevent errors and ensure that the electrical system is safe to operate. If you are not qualified to perform electrical work, do not attempt to do it yourself. Electrical work can be dangerous, and it is important to hire a qualified electrical contractor or electrician to perform any work that you are not qualified to do yourself. Hiring a qualified professional helps to ensure that the work is done safely and correctly. In conclusion, the decision of whether to install a panel board in an attic access by pull downstairs hinges on strict adherence to the NEC. Factors such as accessibility, headroom, illumination, and environmental conditions must all be carefully considered.